Once a particle system has been created, you'll have a handful of different settings that you can adjust in order to control the look and behavior of the particles that are being emitted. I'm going to be using a file named Particle Settings to show you some of your options. You can find it in the Working Files folder for this chapter. As a general rule, irrespective of the type of particle system you create, you'll almost always have a series of to get you started type of settings or parameters that you'll want to initially get in place. To show you those controls, I'm going to be using a super spray. Wanting to have my particles emit from the tip of the metal tube, I'll create my super spray in the top view, aiming for the middle of the empty blue ring. Now, creating the emitter in the top window will also determine the direction that the particles will flow, in this case, traveling upward in our scene. Let's go ahead and activate the top view, and we'll create our super spray. Once I've done that, I'll activate the camera view, taking it full screen with the Alt-W keyboard combo. The arrow on the super spray icon indicates the direction that our particles will travel. Over in the Modify column, I'll increase the size of the icon just a bit, taking the size to 20. Why don't we expand our Modify column controls to 2 panes rather than the typical 1? That'll make it just a little easier for us to navigate around. Okay, because the super spray system emits all of its particles from a single point, let's see if we can't spread that flow just a little. In the Basic Parameters category, under Particle Formation, we'll take both the off-axis and the off-plane spreads to 25. In the Viewport Display section just below that, you can control just exactly how the emitted particles are being displayed in the view. Being able to choose between dots, ticks, and viewing the actual particle mesh. There's another option, Bounding Box, which, if using mesh, can substitute a lighter weight boxed shape for the mesh particles. We'll be taking a look at that option in another video. For now, we'll set the setting back to ticks. There's also a control for just exactly how many of the system's particles by percent display in the views. Let's change the percentage of particle setting to 50 and we'll see how that looks different. Why don't we also try 100% for comparison? So the higher the percentage, the more particles you'll see in the viewport. Let's scrub the timeline again. Notice that the particles are only being emitted over the first 30 frames of our animation. We'll change that under the Particle Generation tab. Under Particle Timing, you'll see both a start time and an emit stop time. Emit start sets the first frame when your particles will appear. That value, by the way, can be set to a negative number, giving you a full particle dispersion right at the beginning of your animation if that's what's needed. The emit stop time is the frame at which the last particle will shoot out of the emitter. For our example, we'll set the stop time to 100. Scrubbing back over our timeline, you'll see the difference that's made. When it comes to controlling the actual number of particles emitted from a system, staying under the Particle Generation tab, you'll have 2 ways to control that amount. You'll also hear that setting sometimes referred to as the particle count. Use rate specifies a fixed number of particles emitted at each frame. So using a setting of 10 would create 10 particles per frame. Use total instead would specify the total number of particles formed over the life of the system. This option is good when creating spurts of particles, like maybe fireworks or sparks that you'd see coming off a workshop grinding wheel. Let's take the setting back to use rate and we'll leave the value at 10. Directly below that, under Particle Motion, you can adjust the particle's speed, or better put, the initial speed at which the particles leave the emitter. The higher the number, the faster the particle's velocity. Let's first play things back using the default speed of 10. Let's now see how that would compare using a speed of 2. Why don't we also see how things would look using a speed value of 20? So the higher the speed number, the faster the velocity of the particles. Let's take our speed setting back to 10. The variation under particle motion simply varies the initial speed and direction of the particles. The greater the variation, the stronger and broader the spray. Let's see how things would look taking the variation to 50%. Leaving things continue to play, we'll now take the speed to 5 and the variation back to 0. A couple of other things about the particle timing controls. Below the emit stop, you have the display and tell setting. This specifies the frame at which the particles will no longer show in the view or in the render regardless of any other settings. So you got to be careful. If you use a stop time higher than your display and tell time, the particles will emit, you just won't be able to see them in either the viewports or in the render. Down below that, you've got your particle's life. This sets the lifespan in number of frames for each particle. Now the lifespan is calculated from the particle's frame of creation, not from the first frame of the animation. In other words, if a particle was created at, let's say, frame 30 and had a life that was set to 60, that particular particle would last until frame 90. The size setting for your particles are found under particle size. Let's change the size value to 5. Now, in order to be able to see that, we need to go back to our viewport display, changing from ticks to mesh. There we go. Now we can see the actual size within the view. Let's take that size value to, let's say, 20. We'll start our playback, then change the speed to 3. Let's also change the variation on the speed to 100%. This will ensure that they don't all come out at the same speed. Back under the Particle Size tab, you've got two important settings. One's called Grow 4, the other one's Fade 4. Grow 4 determines the number of frames over which the particle will grow from a very small value to the size that you've set in the size setting. The Fade 4 value, in contrast, determines the number of frames over which the particle will shrink to 1/10 of its size prior to dying off. So Grow 4 determines how long it takes for the particle to reach full size, while the Fade 4 determines once it's reached full size, how long it takes before dissipating away. Now, you've got quite a few different options as far as the actual shape of your particles. For that, we'll go under the Particle Type tab. The current setting, Triangle, is the default particle type, rendering each particle looking like a triangle. This can many times be used with a material that has a noise opacity map for creating good-looking plumes of, let's say, steam or smoke. You also have the Cube option, which renders each particle instead looking like a cube. There's one called Special, this time around having each particle consist of 3 intersecting 2D squares. This comes in handy when again creating a particle that uses a material face map setting and an opacity channel, wanting that particle to ensure more of a 3D look or effect. Facing type particles create 2D squares that always face the camera. Most of the time, this will be your particle type choice when using a material mapped onto the particle system to create the effect. Now, one thing to be aware of when using facing particles: they're only designed to work in either the perspective or camera viewport. And there's a couple others. Constant. You've got one called Tetra, which is ideal for creating raindrops or sparks. There's a 6-point particle type, and then there's also spheres. Now, those are considered to be standard particles. Under particle type, you've got a couple other options. Metaparticles, which actually blend the particles together in blobs or streams, are ideal for creating flowing liquids, like maybe water or a mudslide. The setting is very render intensive, so just be careful when making your adjustments. There's also the Instance Geometry type, which gives you the opportunity of picking any object in your scene as the particle type. This can be used with individual objects, things that are linked together, even groups can be used as instance geometry. Let's take the particle type back to standard and we'll switch over to using cubes. Under rotation and collision, you can control whether the particle spins, and if it does, just how fast or how slow. It's the spin time setting that determines the number of frames each particle will take to do a 360-degree rotation. If set to 0, you'll get no rotation at all. We'll take that value back to 30. Variation can be used so not all your particles spin at the same rate. Here's the way things would look if we took that value to 50%. Down in the particle spawn category, you can generate additional particles from the original particles, choosing between a handful of options as to when the new particles spawn and what happens to the original particles when the new ones hit the scene. An example of a spawn would be maybe what happens when the sparks from a grinding wheel hit the floor. That collision causing the original sparks to break into many smaller pieces. You can set that spawning activity up using these controls. And you many times also get a series of preset buttons on a particle system. Pre-configured or pre-programmed effects that you can pull right off the shelf and add to a scene. With the Super Spray, you've got everything from bubbles to fireworks to welding sparks that you can choose from. Here's what the bubbles would look like. There's your fireworks. You've got one called hose. Here's a preset called shockwave. And here's the particle look that's generated using the welding sparks. So there you go with a bunch of different settings that you'll be constantly using when configuring your particle systems. Each will be important in getting your special effect looking the way you want it to look.